The next rule that we are going to discuss is a special case. When numbering to the first branch is the same from either the right terminus or the left terminus, we are going to number overall from the side, which gives all substituents with the lowest possible number. So our example here are that if we number from the right, the first branch is at carbon 2. If we number from the left, the first branch is at carbon 2. But there are 2 branches at carbon 2 from the right. And so that would result in 2 numbers with a 2 and 1 number with a 4 if we number from the right. So we would get 2, 2, 4 from numbering from left to right, or if we number from right to left, we would see 4, 4, 2. Why won't this work? Okay. 4, 4, 2, numbering from right to left. And the lower possible numbering is to have 2 2s and only 1 4 versus 2 4s and 1 2. And one way to quickly confirm would be, again, to take the sum of all of the substituent numbers and compare them. So we're comparing 2, 2, 4, which equals to 8, which is less than 4, 4, 2, which is equal to 10. So 2, 2, 4 is the correct numbering option. In example 2, we have that whether we number from left to right or right to left, the first branch is at carbon 3. If we number from right to left, however, the second branch is at carbon 4, whereas numbering from left to right, Numbering from left to right, the second branch is at carbon 4, where numbering from right to left, the second branch is at carbon 5. And so because 4 is less than 5, then the correct numbering would give us 3, 4, and 3, 4, and then 6 for our substituents rather than 3, 5, and 6. And again, you can confirm that by doing an addition problem. We would have 13 is less than 14. So that the numbering 6-ethyl-3,4-dimethyl is correct. And what we're looking at there is the numbering for the next branch point. When the first branch point is equal either from the right or the left terminus, look at the number for the second branch point to determine which terminus to number from. Okay. Well, if we only have, and then another rule, if we have only 2 branches and the branching is the same either from the right or the left, then the lowest number goes to the substituent that comes alphabetically first. So our examples here are a 4-carbon chain with a chlorine substituent and a bromine substituent. Well, bromine comes alphabetically before chlorine, and so I'm going to number from right to left in blue. And so that we have 2-bromo-3-chlorobutane using our numbering. We have an example above of when there is not the same numbering from both sides. Here we would number from where the branch point is first. So bromine is on carbon 1, chlorine 2, 3, 4. So then this would be 1 bromo, 2 chlorobutane. Then looking at another example, whether we start from the left or the right, we have a branch point at carbon 3. And so we have to look at what those branches are. They are ethyl, 2 carbons, and methyl, 1 carbon. Because E is before M in the alphabet, then ethyl comes first, and we number from left to right. So this should be 3 ethyl, 5 methyl heptane. For branch substituents, when we have the longest chain with a complicated branch, a branch that has a branch, the naming can become more interesting. So for branch substituents, we name the substituent separately, and we put this in parentheses. If we look at the first example, we have 3 carbon branch. However, the longest chain of that branch is only 2 carbons, and we can highlight that branch in blue. The longest chain of that branch, the longest continuous set of carbons is 2. And then at carbon 1, and carbon 1 is always the carbon bonded to the main chain. Ooh, I didn't want that. So the carbon bonded to the main chain is always carbon 1. The longest continuous branch going from carbon 1 is 2 carbons. This is an ethyl. And then you have to number the substituent with where is the branch that is on the branch. And it's connected to carbon 1, so that is 1 methyl ethyl. So here is 1 methyl. And then this part is ethyl. 1 methyl ethyl. Next, we can look at another branch, and in this case, the longest continuous branch from the carbon bonded to the main chain is 3 carbons. Highlighted in red. And at carbon 2 of the branch, there is another branch, and that is a methyl group. And it's connected to carbon 2. So that is 2 methyl bonded to propyl. So in parentheses, we would have 2 methyl propyl for this branch. And then we would name the rest of the molecule. We have a number indicating where that branch is located on the main chain, which is carbon 5. And that the main chain is 10 carbons, so it is a decane. Okay. Then looking at the next example, highlighting the longest chain, the longest continuous set of carbons in this branch. Why? With a highlighter is 2 carbons. And then connected to carbon 1 are 2 methyl groups. So we would have 1, 1. So this is 1 methyl. And this is 1 methyl. So there are 2 of them. So we call that dimethyl. And then the portion highlighted in blue, the longest chain on the branch, is ethyl. And so that would give us 1,1-dimethyl ethyl in parentheses at carbon 5 of the main chain. Okay, so then I have an example from the previous slide that we were looking at. And this has a substituent at the longest chain is 8 carbons. We have a substituent at carbon 2, which is methyl. A substituent at carbon 3 that is chloro. And then a substituent at carbon 5, which is branched. The longest chain in our branch is that we have carbon 1 and then carbon 2 as our longest chain in the branch. Then there is a branch off of the branch, which is a methyl group on carbon 1. Then the 2 carbon piece is called ethyl, and that has to go in parentheses. So at carbon 5, we have parentheses 1 methyl ethyl, close parentheses, and then you can name your structure. And what we're going to do in this case is still using alphabetical order. C will be first, so we have 3-chloro, followed by methyl because the no letter is alphabetically before the letter E. So not having a letter at all is alphabetically comes before letter E. So we have 3-chloro, 2-methyl, 5-parentheses 1-methyl ethyl, close parentheses dash octane. And that is how that molecule would be named. Here's a little quiz that I have given previously. I think that it would be a good exercise for you to go through these questions and see how well you can answer them. I think I will add an assignment where you can upload your answers. This will simply be a completion credit showing that you were participating in the activity. And then I will give everybody 1 bonus point that successfully draws this pentanol.